Welcome to Type 1 Error, the podcast where I look at the scientific fact or fiction behind your favorite sci-fi pop culture. My name's Natalie, and today I'd like to invite PhD student Zac Holmes onto the podcast. Zac, how are you going?
Yeah, thanks. No, it's good to be here. Talk about lasers, Star Wars,
Yeah,
everything good.
that is good. Yeah, it's always nice when you get to use some of the knowledge to look at ridiculous things.
Yeah.
Yeah,
Well, yeah, we'll find out if it's ridiculous or not. So,
we will.
yeah.
Could you tell me a bit about what sort of research you do?
Yeah, so I am 4 years into my PhD in laser physics. So the stuff that I sort of do falls under experimental physics. And I basically spend my days looking at lasers, building lasers, testing lasers. And sometimes those lasers work, sometimes they don't. And technically, I'm doing my PhD in OSGrav. So we're looking at how lasers apply to something called gravitational waves, which is like, black holes out there in the universe. They find each other, they spiral into each other, and they emit ripples in space-time as they start to collapse in on each other. And so we need lasers to measure that, and I'm trying to look for better lasers that can help do that in future detectors for gravitational waves.
Okay. So does that rely on, I also don't know, full disclaimer, I did physics to year 12 and then never touched it again and said that can get the fuck away from me.
Yeah, no, fair enough.
Yeah. So is that sort of revolving around the principle that light can't escape the black hole either? So if you sort of shine a laser into or around a black hole, you can see how it's
Yeah,
working?
so if we could do that, that would be, I think we'd learn some interesting physics. But really, what we do is we use lasers for interference. So I think around year 11, interference of light is covered, and light can constructively interfere or destructively interfere. And we sort of get a Michelson interferometer, is what we call it, which is like an L-shaped detector that sort of acts like an antenna, and we send light up and down it in two directions. And as it combines, we can tell from the interference pattern or the level of interference between those two paths whether space-time has been stretched or compressed in one of those paths compared to the other. And so as the gravitational waves come to us all the way from out in the universe where those black holes, spiral into each other, we can measure what those distortions in space-time are. So it's all done on Earth. It's sort of like an antenna. We just listen and then something comes to us.
Okay.
Yeah.
So are you sending out like two beams of light that are either constructively or destructively interfering,
Yeah.
and then they're bouncing off something out there, and if it's being stretched by gravity, then you'll see a change in the pattern of that interference, so when it
Yeah.
returns to you, you'll know that something. So how does it work so that both beams of light don't just get distorted the same way?
Yeah, so gravitational wave detectors, Einstein theorized it in 1915, I think it is, around then, general relativity. And it took 100 years to just have the technology to actually be able to measure it. So there's a lot of stabilization that goes on in the detectors. Things like the detector in Louisiana, you have alligators bumping around, can measure things like that. When someone opens and closes the fridge, just inside the sort of structure there, or they detect storms coming in off the Pacific. There's a lot of things that can interrupt what's happening with those paths. And there's a great deal of, I think it's the highest precision experiment performed by humankind. So,
Wow.
yeah,
Okay.
it's very hard to make sure that those distortions don't take place. And the only thing we actually measure is the space-time distortion.
Okay. It's
Yeah.
already starting to be. That's why we need people like you doing physics and not people like me doing physics.
Yeah, no, it's I'm 4 years into working in that sort of space, and it still boggles my mind. It's a very esoteric field of physics, I think.
So this might be a tangent, but when you said like shutting the fridge door,
Yep.
is that sort of measuring disturbance in sound waves, even though that's a different kind of wave? Or are we still talking about light disturbance or
Oh, that's a
interference?
good question. So, it's just things from when you open the fridge or close it, maybe something electronic triggers in the mains power. Maybe
Hmm.
that ripples through somewhere. Could be sound coupling into the table somewhere. vibrations, things like that. So there's a whole host of things that are light, heat, gravity even. So if a whole bunch of tourists flock to the detector, maybe that does something.
Mhm.
So yeah, all kinds of things. It's a
So does
difficult
the
problem.
detector just detect energy in sort of any form then?
Oh, not as much as it's basically anything that could interact with the, I suppose, molecules even of the mirrors that we use and the laser that we have. So lasers, for instance, a lot of people probably use them when they just flick a switch and the laser turns on. But in actuality, when you build them, you have to be careful that everything's sort of stable and not, even vibrating at a, hundreds of nanometer level or, millionths of a meter kind of
Mhm.
level. So for engineering, which is this sort of in that space a little bit, the enemy of engineers are vibrations and temperature and all these things. So it all couples in like that.
So is that such a problem because the aim is to keep the laser beam, is it coherent? Is that the right word? No.
Coherent, that's right.
Coherent.
Yeah,
Oh my god, it surfaced from somewhere in the
yeah.
depths of my brain.
Back from year
Um
11 physics.
thank you.
Yeah.
So you're trying to keep the laser beam coherent and all the light in the same not the wavelength, in the same
Yeah,
interference pattern, and then
yeah,
having little things like changes in temperature or a rattle on the mirror or someone coughs or something is going to interrupt the coherency of that beam and cause a
yeah, no,
problem when
yeah.
you're trying to use that beam to measure something else.
That's exactly right. So I guess frequency is one thing, and you need the frequency of the laser light to be the same or the wavelength. But then frequency is related to frequencies how many cycles a second. If you stabilize it enough, you'll be talking about what part of the cycle is actually where, and that's what we call the phase of the cycle. Anything that can interrupt that phase is going to be something detrimental to actually detecting the gravitational wave. So we try and stabilize it where, you can imagine we use light at what we say 1 micron. So the wavelength's 1 millionth, of a meter. And we can stabilize it or we need to stabilize it in the detector. So we just have, it doesn't fluctuate much by one whatever part of a phase or something. So you could have the mirrors could be shaking. You could have the mirrors get really hot and deform, and then it forms like a sort of lens. So it's all from the atomic level up to macroscopic objects. It's a very complicated machine.
So I guess then that brings us to Star Wars
Yeah.
lightsabers and how that works. Yeah, so before we sort of dive into whether those kinds of principles are happening in Star Wars or what you think about that, what's sort of your history with Star Wars?
Star Wars is, I guess, as I get older and older, it really hits home with the nostalgia from when I was a kid. I reckon
Yeah.
I've watched the prequels and I forget what the
The original trilogy?
original. I always get lost with the sequels now. The prequels and the original trilogy, I've probably watched those maybe 20, 30
Mm,
times in my life. So it's a lot of hours of watching movies.
yeah.
Used to have it on a little VCR about that big, when I was like maybe six, and just used to put it in all the time, back when VCRs were a thing. And it was definitely a sort of, as a kid growing up, you have the light side and the dark side, the heroes and the villains. And as you get older, you tease apart the themes of society and
Mm,
stuff and, look at it in that sort of lens. And the whole universe and characters and all these things really sort of maybe it probably contributed to my worldview in many ways and
wow.
resonated with me. And yeah, using the force, that'd be really cool. So it all touches on a lot of aspects. The sequels, I enjoyed them with that
Hmm.
nostalgia hit. Probably
Hmm.
feel the same way as a lot of people though, where maybe the younger generations would enjoy them more than I enjoy them.
Maybe this is the start of the sign that, like, being in your mid to late 20s is starting to get old because
Yeah,
I
yeah,
feel
yeah.
like when we were kids, I assume you're a couple of years older than me.
I am 27.
Yeah, okay.
Yeah,
Like, I feel like more around being a teenager and a kid, people were like, the prequels aren't real
yeah,
Star Wars. But now
yeah,
it's sort of the point where we've accepted the prequels, and I really liked the prequels, just saying.
yeah.
And now I'm dunking on the sequels.
Yeah, 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 yeah. I think it's just that nice age to be bitter about new things when the old things were cooler, and You know, no, I
100%.
really enjoyed the prequels a lot, and I always felt like I was in that camp that seemed a bit counterculture of the prequels are really good.
Yeah.
You know,
I don't know why it was such a minority of people enjoying the prequels. I
yeah,
Every time I watch it, I actually just my heart breaks in episode 2 and 3 because it's just so fucking sad. Like, here's someone with the skills and love for his wife and, all he wants to do, and there's all this political bureaucracy that just
yeah,
lets him down again and again until the only person that helps him is you know, spoiler alert for people that still haven't seen the prequels, is like the chancellor, but
yeah, yeah. I mean, they've had their time. They've had their
they've
chance.
had the time. They've had like 20 years. It's fine.
Yeah, but yeah, no, absolutely. And then that sort of just that desire to just beat death. As I get older, I think as I watch them, when I was a kid, I've just, death, oh, whatever, it's not going to happen to me or my parents or something anytime soon.
Oh,
And I
yeah.
didn't experience a lot of death growing up, so it must be different for me. But as I get older, that little desire to beat death is definitely, I can see how that would drive someone, you know, to do that, to turn, I guess.
And it's not even for his own self-interest. There's so many things. This is a whole extra topic, but
Yeah.
there's so many things in culture about like immortality and invulnerability and like the elixir of life and things. But I think what
Yeah.
is most great about Anakin as a character is that it's not for him at all, really. He just wants to
Yeah.
save Padme.
Yeah, and touches on that whole concept of, like me personally, like what would I do for the people that I care about?
Mm. How far would you go?
Yeah, I'd probably do more for them than maybe to stop my own demise. I don't know. Just to watch someone else, it happen to someone else is different, I suppose, to it happening to me.
We can talk about lightsabers then. There isn't actually very much in the Star Wars original trilogy and prequel on how lightsabers actually work and things. But I did a tiny bit of digging, and I don't know if this is sort of bonus stuff or if it's, I don't know, a fan theory that
Yeah.
got turned into canon. But
Yep.
basically, they're described as operating like luminescent plasma beams with a metal
Hmm.
that have a kyber crystal at the center, and this kyber crystal is meditated upon by the force user until it fixes at a certain color that I guess matches their temperament or something.
Yep.
The Sith break those crystals with, I don't know, hate or bad vibes or something, so they turn red, and the lightsabers themselves are wielded like swords. I know you know this, but the
Yeah.
lightsabers are wielded like swords. They can cut and burn through things, through almost anything except for another lightsaber beam or an energy shield. So that's what we've
Yeah.
got out of all
Yep.
that lore. It's about a paragraph worth of information.
Yeah, and the only really part of the fabrication of it is just the crystal,
Hmm.
I suppose, and it's a metal hilt. That's
Yeah.
about it to go on. Everything else is sort of the consequence of what it can do.
Yeah.
Um, so, because I sort of did my own sort of googling, trying to find things and thinking about it through, as you said, there's not a lot in the movies themselves or anything canon for that matter, and it's a very difficult problem, I suppose, to say it short. From my standpoint, I'd say in the realm of physics and where it's going and engineering, it's pretty much impossible.
Okay.
I'd want to say
Bummer.
the short answer. And the long answer is, I guess it depends how loosely you want to look at the problem. So there's things like, can you build a stable meter long, well, saber, I suppose is the word,
Hmm.
saber or blade of light? And then there's aspects like, can you make something that can have a color to it that you
Hmm.
can see? And we'll touch on all these different, these are the questions I sort of ask myself for this. Then there's the problem of how do you hit them together and have them actually stop? Because I
As
think
a
that,
physical object.
yeah,
Yeah.
that to me might be the hardest part of all of it. I'd say first and foremost, it's an energy problem, I
Okay.
guess. Was there anywhere in particular you want to start talking about it, or?
I know that crystals, mirrors, and diamonds and sort of other minerals are used in some engineering things, is there a feasible way that a crystal could be, faceted to reflect and refract light, whichever one is happening at that case, into a beam? Or is that something you don't see in lasers, but you might see in like a fiber optic cable or something?
Yeah, so no, that's a good question. I think the interesting thing is one thing that I suppose is real enough about lightsabers is that a lot of lasers are crystal based. So some of the older lasers, I think the first laser was a ruby crystal, and then they make now crystals out of, you know, you dope certain rare earth elements into crystals like neodymium or ytterbium or all these. You remember the periodic table? These are
Mhm.
the ones that sort of sit down at the bottom. They get forgotten about.
That you never had to remember for high school chemistry.
Yeah, the
Mhm.
the lanthanide series, if that means anything. So a laser is in a really simple way just some gain, like a crystal that has excited atoms and things like that, that you can get more light out of, and then it's just got mirrors surrounding it. And the mirrors are actually typically, well, they're glass, really. And sometimes you can have silver coated mirrors and gold coated mirrors and things like that. But the crystal part of it would be where you'd get the energy from.
Mhm.
So we have mirrors that can take a lot of power. For instance, I guess what I'm trying to say is you'd have that gain in the crystal, which would be like the heart of the lightsaber, which is the correct part, I suppose.
So what do you mean by gain? Is that like the electrons being excited and then the orbit's decaying and releasing a photon? Is that
Yeah,
what the
that's
gain
exactly
is?
right.
Okay.
Yeah, so the gain is where, yeah, basically, it's even simpler than that, I suppose. I'm just all lost in jargon
Oh,
because
that's all
I'm my
good.
PhD.
I'll keep you on
It's
track.
basically, yeah, thank you. It's basically you put light in, you get more light out, sort of
Okay.
thing. So gain could also be for electric current or voltage or something like that.
Is that also how fluorescence works?
Fluorescence is instead of having a stimulated process where you hit it with the light that you want to get out and have that coherence.
Mhm.
Um, Fluorescence is just when it drops. The
Okay.
electron
All
drops
right.
to a high energy, and then it could be sort of of a certain wavelength and going in a certain direction, a certain phase. Every laser started off with fluorescence, I suppose, in the sense. So I don't work on fluorescence, so people that do maybe will hate me for that. I don't know, but it's
All three
spontaneous.
listeners will be very disappointed.
Yeah, maybe. I mean, I don't know how hardcore laser people are. They seem pretty hardcore.
I mean,
So
you're a hardcore laser person now, so
yeah, yeah, that's true. I mean, I don't know. I guess it'll be interesting to see this from the outside. But the spontaneous emission has to drop, and then you get it resonating between the mirrors
mhm.
to keep passing through the crystal. And the mirrors are actually choosing what's fed back. So the mirrors choose what particular wavelength that you get. Yeah, essentially, what you need for a laser is that gain. You need the feedback, and the feedback started by just excite the atoms, electrons, and then it starts bouncing around, and then you get that high power beam of light that's very coherent.
Mhm.
And so, if you wanted to make a cool looking lightsaber that didn't really do anything, you'd have to have like some glass tube that you could view through it.
Okay.
You'd have the laser crystal in the hilt, just like it is in Star Wars, and you could have mirrors either end, and then all the light could just bounce back and forth. And the other thing is, the interesting thing about lasers is that if you've ever seen a laser emitting into free space, you can't like empty space, just around us. You can't actually see it unless it actually reflects
Right.
off something.
Yeah.
Yeah, so the hard part as well is you could have this high power beam of light that could cut through anything, but you'd only see it if it actually bounced off something like the air or something like that.
Right.
So if I wanted to make, well, I guess if I wanted to make a really cool laser lightsaber kind of thing just for aesthetics, I could do it, and it probably isn't that different to what you'd buy at like Kmart or something.
I'm sure it'd be a bit more high tech than a Kmart one, but
Yeah, no, that'd be cool. And I guess the next thing is maybe the aesthetics is something I suppose you couldn't just brute force through that. I
mhm.
think that if you wanted a proper lightsaber to cut through things, I think by definition you wouldn't be able to see it.
Right. So if you had the mirrors on on either end, you could have like a discrete blade. So you don't
Yeah,
have the sort of just unending lightsaber that just extends indefinitely into the
Forever.
universe. So you'd need
Yeah.
a mirror at the other end to keep the beam in
Like,
that area. But if you wanted
yeah.
to cut through something like a real laser, you would have to remove that mirror. Oh, no, that doesn't make sense. Kind of.
Yeah, so I mean, the troubling thing is if you wanna have, like, what we'd call, like, a resonator, so the light resonates between and bounces back and forth, that'd be the best bet to get a good amount of power, right?
Okay.
Because then you have this problem where all that circulating power, is what you'd call it, can get really high, um, and you also want it to end, and so you'd need to suspend a mirror somehow at the end of some, meter-long bit, and you and I've got a way to get around this, I think, but the problem is you need to suspend a mirror there. You have so much high power going in between. Can you really have like a really tiny, thin, I suppose, like support beam to have that mirror on? And then if you do that, how do you have a nice, round laser beam that can go through that with something just sticking in the middle of it?
Right. Because the lightsabers are quite thick, but the actual laser would be very small and precise.
Yeah, I mean, because the energy the lasers that I work with, even in the big detectors for gravitational waves, where they want megawatts and more of power circulating in between it of light, the beams don't really get. I can't imagine they'd ever get bigger than, I don't know, what's that? Maybe even 10 centimeters, maybe the most. You can do it. It's just that it makes everything really hard because really what you want out of a lightsaber is what we'd call energy density. So it depends how much energy you have in every little section of the lightsaber as to whether you could cut through something.
Okay. So if it wasn't energy dense enough, it would just be like a cheap laser you could buy at, I don't know, a shop where, it's not
Yeah,
going to burn a hole in your living room, but you can make your cat run around
chase.
and chase it. Yeah.
Yeah, even I suspect even if you used like the highest power laser you could buy, I suspect it wouldn't even function properly as a lightsaber. Well, it just wouldn't function as a lightsaber properly either. And so, because the energy density that you'd need to basically cut through things, I mean, they have laser cutting, machining and things like that, and
Mhm.
engraving and things like that to cut into
Oh,
metals.
yeah. Okay.
But yeah, and those are like, I don't know, like light has a tendency where, so you have that beam traveling inside that tube or something, or not tube, but with a mirror at the end and a
Mhm.
stilt in there, and you'd need to somehow have enough energy at every point to cut through things. But typically, when we cut through things, you'd have to focus that light down to a tiny spot to actually do the
Okay.
cutting. And off the top of my head, thinking about how they do it, that spot is probably something like microns wide or
Right.
millions, maybe 30 millionths of a meter wide, or 200 millionths of a meter wide or
So
something.
the lightsaber is not gonna be the same efficacy or cutting power at every point along the beam?
Yeah, it'd be very hard. So what I'm thinking is, if you wanted to do that, you'd have to have. So basically, the reason we focus it down is to really get away with not having as much power coming from the laser to begin with. 'Cause if you have a laser, if you have like a 10 or 1 centimeter beam, if you can lock that down to 1 millimeter and focus it down, you would have a gain in energy density of, proportionality is not my strong suit, I guess. It'd be 10 to a million. You'd have a gain of, oh, not a million, it's a centimeter, be it 10,000, I think. Yeah. So that's why we focused it down. So if you didn't want to focus it down and had a centimeter running the whole way, and you wanted the same energy that you'd want to cut things that you focus down to a millimeter, for instance, you'd have to have a laser that's 10,000 times more powerful.
Right, okay. Which is a problem for a handheld fighting
Yeah,
sword. Okay.
that's
Yeah.
right. And we can talk about power first, I guess. Just trying to organize this a bit in my own mind. Power wise, could you do that? Like, I suppose the highest power lasers in the world, for instance, right? Pulsed lasers. So they're not emitting all the time,
Mhm.
which again is a problem for a lightsaber because you don't want
Yep.
it to be, just every second or so, or, maybe you could get away with every 1,000 times a second or something. But they're called petawatt class lasers. Petawatt is a million or 1,000 trillion, I think. It's a one with must be 15 zeros after it.
God. Okay.
Yeah. And so those lasers are used for exotic matter and high energy physics and nuclear fusion and things like that. But even getting to that level, if you wanted to cut through anything arbitrarily, maybe you'd have to go there. And we don't even know how to make lasers that can emit like that continuously.
Mm-hmm. Right. So it's a dilemma.
Very big dilemma.
Yeah. The power is a big issue for the scale at which these lasers in Star Wars operate. Sorry,
Oh, yeah.
lightsabers in Star Wars. Okay. Oh, there's so many questions to think about.
Yep.
So, is a laser the best analogy for how it's working, or is there a different, like plasma thing? I don't know anything about plasma except that when you see a fire, you're watching plasma, the flow of electrons.
And that's a really good question because basically what I was going to lead into is maybe light isn't what you want to go with because there's so many problems of, you can't see it, it emits forever. So really, if you used a lightsaber, I would just grab the thing and just point it in your direction and then probably blind you or something, and then I probably win anyway, right?
It's the fight in the volcano. Duel of the Fates? What if that whole battle was just him shining a laser in their eyes, just like, ah?
Yeah, gotcha. And so the best analogy I'd say is, plasma, I'd say is what people really think of. And so with light, for instance, for the aesthetics and getting the, glowing beam and everything,
Mhm.
lasers, the best you'd get is to use a visible laser. And even then you wouldn't see it until you see what it
Yeah.
hits, right?
So visible
But even then,
meaning using wavelengths in the visible light spectrum then?
oh yeah, that's
Yeah.
a good catch. Yeah. So in the visible that we can see. But even then, even if you weren't, and the power scaling, you can get more power out of wavelengths that aren't, I believe, in the visible regime. So
Mhm.
they'd be infrared, so you wouldn't see it anyway. But what would happen is if you were in anywhere with air, which you probably want to be because you can then breathe, you'd
Presumably.
actually see like you'd actually see just like a crackling as the air particles go into the beam and it would ionize. So you just hear like a
Ooh.
crackling pop, and you see just flashing like an electric arc, I suppose. So that's the best you'd get, and that's more like I think in some Star Wars games that probably are definitely not canon. That have like electric whip or something.
Wait, so you're saying that if you did use light for a lightsaber, then you'd probably more likely see very intermittent, random, sporadic flashes as air particles are ionizing.
Yeah,
Air particles, you know what I mean? Particles in the air
yeah,
are
yeah,
ionizing.
that's exactly right. Yeah,
But I wonder if that hum and crackle when you like whip the lightsaber
yeah,
around. I wonder if you could. Does that sound anything like what these ionizing particles could sound like? And I found out also that they came up with a lightsaber noise, and then they used the Doppler effect with the microphone of
wow,
moving
the
the
shift.
microphone phone around relative to the lightsaber noise so that they could make it have a more natural hum as
Yeah,
it moves through the air.
yeah, like a whooshing, and yeah,
Yeah.
yeah. That's interesting. Yeah, because that's a good way to do it. Yeah, so the crackle and pop of the ionizing particles, I've never been in the room where I've seen it happen or heard it, but I believe it's just like a little electric sort of, you can imagine like an electric zap or a pop.
Mhm.
I think that's how it goes. So it would sound very, it wouldn't, I don't think, sound, even if it was whooshing around you and things like that, I still don't think it would be a faithful representation,
Right.
I suppose.
Is it very quiet as well? Would it sound a bit like if you got a static electricity zap and it went like, you know what I mean? The sound
Yeah,
of an
no,
electric static shock.
yeah, because we've all heard it. I guess when I say that, people probably think of that sort of popping, that quick, yeah, the zap. I believe it would. I don't know for sure, but I know that some people around here work with pulse lasers, so they'd probably know because they have an image of like it looks like a rail where, not a rail, but along the, you can tell where the laser beam's going because along its path you can see just a few
Oh, cool.
air particles ionizing, and
Mhm.
I imagine it's just, yeah, like a crackle and pop that sounds probably like a static electric. shock.
Do you know what colors those come up as, or can they come up as anything really?
Yeah, no, it's a good question. So I'd imagine it would be like a bright. So you're not looking at the laser itself. You'd be looking at the electron ionizing, which would
Hmm.
be like that electric arc. So it's probably a white flash,
Okay.
maybe even a little bluish. So it'll depend on how hard the electrons are hit, but it's probably all over the place. So it's probably just a white flash.
Okay. Oh, that's pretty cool. So you could start to see part of a beam if you looked very carefully, and you're hoping that that lightsaber isn't being swung at your head or anything. If you look
Yeah,
very carefully and assuming everything else is right, there might be little tiny flashes of light and a sort of crackling pop. Also,
yeah,
100% just thought of Cocoa Pops when you said
yeah.
like
Snap,
crackle
crackle,
and pop,
pop.
and I was like, oh, snap, crackle and pop. So
Yeah.
Kellogg's clearly got their marketing down to embed that in my brain.
Yeah, and so I guess leading into your question, which is there a better analogy? Would think that plasma would be a better analogy, as you
Mhm.
said. And so plasma is like it's not the fourth state of matter, but it's like when you learn at school, you learn about solids, liquids, gases, and in that order, it's the space between the atoms
Mhm.
and the motion of the atoms. Plasma is this next state of higher energy than gas, where you basically the electrons dissociate from their nucleus. So it's like having the nucleus, the positive nucleus, all the protons and the neutrons, and the electrons are like those nuclei floating around in a sea of electrons, right? And the best example I've got of a plasma is the sun, because that's exactly what the sun is. It's a big plasma, things moving everywhere. And the way that figures in with lightsabers is that you could maybe, so plasmas respond, having a sea of electrons and everything, they're very responsive to magnetic fields,
Mhm.
right? Because magnetic fields basically exert a force on moving charges. And so you could actually, so the nuclear fusion experiments on Earth, for instance, are trying to contain a plasma inside a big, it's called a toroid, I think, like a big donut
Okay.
looking thing, where they can confine it with magnets that direct all the plasma. And so for a lightsaber, maybe you could construct a magnetic field that has some sort of like effect where the force exerted by the magnetic field can direct the plasma up and back and have it
Mm,
circulate.
right.
And that would, you can see a plasma. So any electric charge that accelerates will release a photon or release light. So depending on how fast all those charges are circulating in the plasma, you could probably tune that to be blue, red, green. Wouldn't respond to your temperament, unfortunately.
Mhm.
Maybe the choice, of what that color is maybe a reflection of that.
Mhm.
But yeah, I think the best bet would be a plasma because not only would it meet the aesthetics, it would also meet the ability to cut through things.
Right. Oh, what if you used different based compounds in the hilt to give it like a different flame or plasma color? Like, could you use copper to give it like a green blue plasma sword blade thing?
Yeah, the flame temperature. I feel like I'm back in chemistry when we did all
Yeah.
the
Yep.
different ones, copper flame, and
We just got to burn shit.
Yeah, so it's sort of like put in different little elements, and I'm wondering how much you'd have to put in to actually overpower the general. Like the sun's very broadband; it emits in a
Mhm.
whole bunch of wavelengths because you have a whole bunch of different motions and things like that. So I'm thinking how much copper, for instance, or something you'd have to put in. I don't actually know the answer to that, but it sounds feasible. Maybe you have to keep it injecting, a copper
Mm.
residue or something, and it keeps just blowing out with flames. It'll
Right.
be purely aesthetic,
Yep.
but
Or the
probably it should be.
Jedi are actually just a bit hooked on their, like, Instagram and, "Oh my god, my lightsaber has to be the right color," and they just
Yeah,
keep putting it in every day, like a new,
yeah,
I don't
yeah,
know,
and
canister.
the force just directs it in from the surroundings. I don't know.
Mm. I do like that idea. It sounds like the plasma beam would be better as a functional lightsaber and appearance-wise too, would you say?
Yeah, and so what I'd tie in with that is light would also so plasma would be good because you'd cut things with heat alone,
Mhm.
really. No special interaction. It's really hot and it just cuts through things, and that's good for business if you have a lightsaber because that's what you want.
Yep. Also, good to think about when people do get burned by or cut by lightsabers, it tends to cauterize the wound. So it
Yeah.
does sort of seem like there's a high temperature burning thing happening.
Yeah, so it like sort of, cuts it on the way in, seals it on the way out sort of
Yeah, it's
thing.
very efficient. It's a terrible way to kill someone. Like, wouldn't you want them to bleed out to death? But instead, you're just like, hey, here's your wound, but I've just sealed it up again for you. Be on your way.
Yeah, the best way I could amputate your arm because it just fixes it as I do it.
Yeah. And maybe this is why Darth Vader managed to survive in a volcano for so long, because Obi-Wan just
Yeah,
cauterized all his wounds. So, anyway.
yeah. And yeah, because the thing, I mean, lasers are used for that, where they can actually open people up and then seal them up. The problem with lasers is that you need to have a particular wavelength to actually cut a particular
Mhm.
material. For instance, the lasers that they'd use that respond to metals respond to cut things and weld things, if you directed that onto a person, maybe it'll do some damage, but it won't do perhaps as much damage as it does to the metal.
Okay. Didn't even, yeah.
And so for instance, some of the work that I do is research translations, a sort of buzz phrase sort of thing people are throwing around. And we're looking at doing research translation for some of the lasers that I work on to kill weeds.
Wow. Biological, like environmental weeds?
Yeah, so
Yeah.
things like instead of using chemicals, you could go
Mhm.
to on a crop. You could have maybe a tractor. They do this already in the states commercially. The tractor has a bunch of lasers on it, and it goes around the paddock or the you know crop, and it
Mhm.
just finds the weeds and it just zaps them until they're not going to grow back, or if they grow back, just go hit them again.
That's
And
amazing.
yeah, and
That's
it's
really
it's
cool.
we're looking at doing that. We're doing that with the Wait campus, the agriculture campus. The shout out to the I think it's the plant phenomics facility. And so we went there a few weeks ago, and we are using a 2 micron laser, so the wavelength is 2,000 nanometers. So it's heavily absorbed by water,
Okay.
right? And the water in the weeds is what we target, where we heat the water up to, maybe 40 degrees Celsius or 50 degrees Celsius, and then it just destroys the rest of the weed. And if you hit the water harder or you use more power, maybe you could just cut through the weeds and something like that. And so it's a similar conversation with people because people are made of mostly water. And if you want to cut through a person or do damage to a person, it's probably a good thing to pick the what we call the absorption line of water. But then you do that, and also to say it's against the Geneva Convention to make lasers that hurt people. So
Mhm.
I'll throw that out there. Not that maybe some people do it, but it'd be a very illegal thing to do. But anyways, you'd want to use something that targets water, and then as you hit the skin, all the water will basically suck up all that energy and just perhaps if it's enough energy blow apart the flesh or something.
Right.
And then you'd get to the bone, which is not really made of water,
Mm.
I'd imagine. And then the laser would just not really do anything.
Right. I have sorry, I've just been busting with questions. So, with the weed cutting or anything, where you're cutting through a material, are the lasers in those studies, are they using the fact that a weed might have a different spectral signature for like NDVI? It's where, yeah, you're using the reflectance of the light off the plant to know how healthy it is. So obviously, like brown plants that are shriveled
Oh,
and dry are going to have a different spectral signature to healthy green ones full of water that are reflecting the green wavelengths back. Is it targeting weeds by using the difference between that and the known plants? Or is it more that weeds tend to hold more water, so they're more susceptible? Do you have to pre-program a bunch of lasers with this kind of weed has this water content and this sort of spectral signature and is structurally different? Like how does it differentiate?
I suppose you could do that, but it's actually just machine vision. So
Okay.
basically, you need to train a machine learning algorithm to know this is what this type of, like ryegrass, for instance,
Mhm.
it's got a lot of tendrils coming out of it, a lot of blades of grass. So it actually, the machine learning algorithm learns. Have you ever been to like Botanic Gardens or something and you've
Yeah.
used an app? Yeah, that
Yes.
finds yeah, it's the same way that happens. So the machine vision is quite mature. You can actually buy it commercially they actually spray herbicides sometimes like that, where it just takes the image, the structure, I suppose, more and the length of the features of it to
Mhm.
determine what's a plant to get rid of and what's a plant to keep.
Right, okay. As a botanist, as part of my job, I'm like,
Yep.
"Ooh, I feel like there's a lot of very subtle differences between many weeds that you need to have a trained eye to look, so maybe it works really well for some weeds and not others."
Yeah, definitely not my expertise. I just want to, heat them up and get rid of them.
Yeah.
But yeah, no, the biggest function is basically the machine vision will pick out. Maybe what you do is different weeds respond to different amounts of power.
Mhm.
So you'd have a machine learning algorithm that would say, "Oh, this is ryegrass. It looks like it's 3 weeks old. Hit it with this much power and hit it at this point." That's what it
Okay.
would say. Yeah, and trying to hit the different materials and things like that. For plants, I mean, I suppose, like I've actually done some tests in the lab. When you actually boil away the water and it's just the brown material left, the laser actually doesn't do much at all.
Oh, okay, because it's relying on heating up the water to destroy, yeah, the plant.
If
Okay.
I was in a lightsaber fight or expecting one, and I know that their lightsaber hits water, I would just wear metal, I guess.
Mhm. Darth Vader, maybe that's why he wears metal.
Yeah.
Unless you would have to, if you know you're fighting Darth Vader, you need to get a special, like, metal wavelength lightsaber to cut through that, and then once you cut through the armor, you swap back to your normal one. But, I mean, I
Yeah.
guess the lightsabers have also, that was a superb tangent back to the point as well. Congratulations. But, I guess there's still, like, buttons on a lightsaber. So I wonder
Yeah.
if you could hypothetically say, oh, if there's buttons on the lightsaber, maybe you can have it pre-programmed to detect the, I don't know, the water susceptible wavelength at which that will cause some damage. And so maybe it's calibrating that as you're fighting to cut through the material that's like
Yeah.
in the immediate vicinity or something. This is such a stretch.
No, no, no. It's a good segue into the next problem I was going to bring up with
Mhm.
it. But first, yeah, like that's probably what you'd have to do, and then it changes everything about the lasers you're using. So if you needed 6 different wavelengths, to hit 6 different materials, you'd need 6 different laser systems, all slightly different, all chewing up a lot of power, and you need to have it all in the hilt and exchange it,
Mhm.
and just makes everything worse, I guess. But you sort of need to do that because in the laser weapons that do exist today, which are used to target unmanned aerial vehicles or boats or things like that, that's how they get around it. They just put something there that's highly reflective or put a different
Mm.
material, knowing what they're going to hit you with. But the best thing you could do is just, if I was going to fight a Jedi, just little old me, I just bring a button. And they had a lightsaber that exists in our physical universe. I would just set off a smoke grenade or something because
Mm.
lasers don't do well in atmosphere. They suffer things like filamentation and diffraction and
So all the particles of smoke and crap would scatter all the light, like the
yeah,
light beam interrupt the coherent pattern,
yeah.
and it's useless as a laser.
Yeah, I mean, that's what they do where you could just emit a puff of smoke from your boat or something when you're out
Mm.
in the high seas, and then they can't direct it there and focus it down because it's that focusing down part and keeping that. I suppose the coherence isn't as much of an issue as just being able to focus that power down, which I suppose is the same thing, I guess.
Mm.
But yeah, I would just have if I was doing that, I'd just have, I don't know, puffs of smoke coming out of my armor or something
I
and shot
think it
through.
would be a real power move if there's like, a supreme Sith Lord or something with a lightsaber. And I can picture Han Solo doing this of just sort of kicking back and like smoking a cigar and just
Yeah, like everything.
it's just crumbling around him. But
Yeah,
we're getting a bit close for time, so I'm gonna go for one more question before we wrap
sure.
up, if that's okay.
Yeah, absolutely.
What would happen if you brought the two plasma beams together? Or the lightsaber. I mean, we talked a bit more about the lightsaber beams being brought together, but if you tried to
Yeah.
have two plasma swords and have them fight each other, is anything going to happen?
So I saw one thing on the web. I was reading up on something called the light-light interaction or
Hmm.
light-light scattering, and they were looking at how could you get, so off the top of my head before I read it, I'd say absolutely not. Light comes together, it just goes straight through. It just doesn't interact. And so they had this really outlandish concept that was, I guess, feasible, where sometimes light can find its way to interacting with other light particles, and it's in the realm of something called nonlinear optics, where the light can bounce, scatter off each other. For instance, I don't know how embedded in the real world it is, theoretical physics as you do,
Is
but
theoretical.
in the Large Hadron Collider experiment, I think they detected it at some point where, yeah, light can bounce off each other,
Okay.
and
Oh,
what they were
bounce
looking
off
at
each
is,
other.
yeah, like collide and
Oh,
because
cool.
that's what you need, right?
Mm.
Some sort of, you know, you need some macroscopic reflective surface, right? That could just be like, reflected off. And they found that you'd need an insane amount of energy to do it, which becomes problematic because if you used the highest power lasers in the world, you'd have to pack so much stuff in the hilt of the lightsaber that if you grabbed a hold of it, well, its gravity would just suck you into it, and the blood from your fingertips would be sucked out of it just from the gravity of how much mass you need to put in the hilt.
Oh my God.
Yeah, it's for matter antimatter annihilation, just to get the energy.
Yeah. Would you mind sending me a link to that paper
Yeah,
or something? Then I can just put in show notes
yeah,
and
no,
I don't know
absolutely,
if
and I'll
there's
send
any
that through.
physics nerd that will be able to understand it, but hopefully.
And what they wanted was to use I don't know how to make this really intelligible, but the 0 point fluctuations of the vacuum, which is that if you've heard of Heisenberg's uncertainty principle, if you remember that back in, I don't know if we
I've heard the name.
yeah,
That's
so
about
it's
it.
basically you can break energy conservation for a certain amount of time, so long as it's short enough that it doesn't break the uncertainty principle, which is just that you can't measure things that precisely, because if you measure a time interval this precisely, the uncertainty, the energy goes up, right? And
Okay.
vice
I
versa.
definitely had never heard that before. That does not sound familiar at all.
So it's the thing where maybe you've heard of, you can, if you measure the position more precisely, you don't know where it is as well. Have you heard of that one?
You mean trying to like pinpoint the exact location an electron might be in an
Yeah,
orbital?
like the
Yeah.
better you know that, the less you know where it was going or how fast.
Right. Okay.
Yeah. And so in a vacuum, you can't have zero energy, right? Because you can't know that it's zero energy. So sometimes there's fluctuations around that, nothingness, I suppose. And they were thinking you could use that if you had enough power, then you could use that for those fluctuations to create enough photons or something that could then scatter the photons in your laser beam and then have something that feels solid to hit.
So, sorry, there's a lot of info to take in. So,
Yeah,
if you
sorry.
had two beams crossing each other,
Yeah.
if you somehow, as part of your immensely smart AI lightsaber hilt, if it could pinpoint the precise location of the electrons in the other beam, then you could potentially target that and so hit a solid object.
Well, so it's not that as much as I think it's just you can have enough power and enough photons in your lightsaber and in their lightsaber that when they come together, you have. I'm not really sure actually. It's just that, yeah, the energy density of it is so much that the light and the light from both lightsabers hits together, and you get that light interaction, that scattering off the light.
Okay.
And the vacuum. I'm trying to think now actually where the vacuum comes into it, but maybe that's what scales with power. And the interesting thing is, together they calculated the recoil, because that's what you sort of want as
Oh
well,
yeah,
right?
it
That real,
bounces
yeah,
off or something.
feeling. And what they found was that since it forms a reflection, like a reflective sort of surface, that if you're holding the lightsaber, say like this, and you had a beam of light like this, the light interaction is not at right angles to your beam. It's actually parallel to that beam. So what
Yeah.
you do is you'd swing it, you'd make contact, and the recoil would just maybe be strong enough that the lightsaber just shoots through your hands.
Oh
Is the way it
god.
works.
Okay.
Yeah.
That's
And
not
then,
ideal.
yeah, that would happen if you reach the center of the beam. But as you're going into the beam, it creates a torque on the hilt. So you'd have a twist as you're going towards it, and then the recoil would just shoot the lightsaber through your hands. So you just like hit it and spill it.
So you could, if you had two lightsabers and you tried to put them against each other, there is the chance that, considering all the right power requirements and things, that it's not just going to be two lasers passing helplessly through each other. You
Yeah,
could get some physical contact, but it's going to be super unpredictable, and it's probably going to end up with a laser going through your hand or bending the hilt
yeah,
from the recoil. Okay.
yeah. So it would not feel natural like a sword or something. It would just be like,
Just be
I don't
weird.
know. You'd have to have very strong wrists, I imagine. So maybe the force can help with that. I don't know.
Yeah, maybe the force helps give them natural wrist guards. I don't
Yeah,
know.
and they
Yep.
just lock it in.
Cool. So that's probably all we've got time for, though. This has gone really, really quickly. I've got one more question.
Yep.
Have you heard of the Darth Jar Jar theory? And what are your
Oh,
thoughts
how
on it?
I
That Jar
have.
Jar Binks is actually the true villain who plays a bumbling idiot character that's
Yeah,
incompetence threatens everyone and destabilizes everything, and he's actually a Sith Lord mastermind.
yeah. So I'm sure that's not just canon just yet, but
Okay, not quite.
yeah, not quite. Maybe the next trilogy.
Oh
I
god,
have
no! Don't give them
no.
ideas. Honestly.
Yeah, because yeah, it's like how in the original trilogy, how you
Hmm.
don't really you take for granted that the emperor is there, this darker figure that is actually pulling the strings.
Hmm.
So maybe to the emperor, that's what Darth Jar Jar is.
Mm.
You
He's
know?
actually the puppet of the Sith Lord Master.
That's how Palpatine had that whole frail old man sort of wise old man gentle shtick that he pulled
So you
while he
do mean the the prequel trilogy, not the original trilogy.
Oh, I was just saying in the originals, way back when the prequels didn't exist,
Hmm.
people didn't realize there was this emperor that was looming.
Oh yeah, I guess he wasn't much of a presence for a lot of it.
Yeah, and so you just think it's all Darth Vader. He's the only singular, monolithic bad guy, and then you realize there's someone else. So maybe, yeah, to Palpatine, that's what Darth Jar Jar is.
Maybe it all just happened and we didn't. He was so good. He was never caught by
Yeah,
the Jedi Council, so that his story was never told.
yeah, and he's been there. I think I read something else about maybe he's the every time Darth Plagueis or whoever's before him dies, finds a new vessel.
Oh yeah,
And
and
maybe,
maybe he's been disfigured and deformed by this transfer of consciousness of the Sith. So that's now what Jar Jar looks like.
yeah, yeah. And then, because he's supposed to be so stupid and silly and whatever, but he always finds himself at powerful positions and, with powerful people.
He
So,
doesn't die, so just
yeah.
saying. So as we finish up, I'm gonna ask one more question, which is probably fairly easily answered.
Yeah.
But if you could rate the Star Wars lightsabers from science fiction to science fact,
Yep.
fiction being 1, it's all rubbish, and 10 being this is a pretty accurate representation of science, what would you rate the lightsabers as?
Ooh, I really want to say one science fiction.
Okay,
Yeah. Just
solid.
because, yeah, I mean, like science, maybe I'll think on that one just because I guess it's the engineering that's some of the biggest problem to it. So,
Hmm.
maybe it's not too bad as one, but yeah, I kind of feel like I want to say one.
Okay, yep.
Yeah.
I am going to agree with you because I don't know enough about physics to have a proper opinion on this. But also, based on everything you've been saying, it really sounds like the technical limitations of energy and power and, how a
Yeah.
laser actually works. It sounds like it's not going to work as a functional sword
Yeah, it's a
or
bit
lightsaber.
outlandish, but I would love to have one, even if it just whooshes. Maybe I'll go to Kmart
It'd be
after
cool.
this and just get one. Yeah.
Yep. Yep. I'm glad this has inspired you to
Yeah.
get a Kmart lightsaber.
Yeah.
Well, thank you so much for joining, Zach. It's been really interesting, and you explained everything really well. I didn't
Hope
feel
so.
too left out of the physics jargon. So
Yeah. No, thanks, Natalie. Yeah, it's been good to join, and it was good to reflect on lightsabers as I watched the movies and think about could I make one of these, one day.
Great. Oh, do you have anything you'd like to talk about? If you have any papers coming out or if there's anything really cool you want to talk about?
I wish I had some more papers coming out. I don't work in, I think lasers is a bit of the space where, I don't know, it takes a while and sometimes you
Hmm.
get lucky, sometimes you don't. Shout out to Osgrav and the Centre of Excellence that we've got that just got renewed. I sort of a slightly different version. I guess I'm not really part of the bureaucracy, but 7 more years of Osgrav, I guess, which is the research collaboration that I'm a part of. So if you're interested in gravitational waves, black holes, lasers, optics, all that sort of stuff, check out osgrav.org, I guess it is.
I'll find it.
Yeah, and engage. And if anyone has any questions or anything, reach out to me.
Great. Do you have a Twitter account or anything if anyone has any follow-up physics questions for you?
My handle is Oz_Zac. Yeah, happy to receive any questions or comments, or as long as they're worded nicely, that's all good.
Yeah. Well, they got to fit them into 240 characters, so they can't be that bad, can
No,
they?
that's right. Can't
I guess.
dismantle all my theories and things.
Well, thank you so much. Have a great day.
You too.
See ya. Thank you for listening to Type 1 Error. This podcast was created, edited, hosted, researched, and produced by Natalie Brown, and the music is also by me. The excellent cover art and logo is by my sister Alexandra Brown. This podcast is currently non-monetized, and so the best way to show your support is to rate, review, and subscribe to Type 1 Error wherever you listen to podcasts. At the time of recording, Type 1 Error is available on Spotify, Google Podcasts, iHeartRadio, and Podbean. Reviews are really important to establish a new podcast, especially since it costs me money to produce episodes. You can also engage with Type 1 Error on Facebook, Twitter, and Instagram at the links in the show notes, or join the Facebook group, The Type 1 Errors, for community and episode discussion. For questions, feedback, or episode requests, email me at type1errorpodcast@gmail.com with the one spot with the number, not the word. Remember to keep your curiosity every time you consume your popcorn. See you next time.